Good day, everyone, especially to our instructor, Engineer Chu. My warmest greetings to you, sir. My name is Angel Einstein, and I will be reporting my final project for techniques in metallurgical analysis. So the topic we'll be tackling today is classical methods of analysis and instrumentation method of analysis. Now, I will be first reporting the classical methods of analysis. In all modern mining fields, the fire assay of copper is replaced by the volumetric or electrolytic methods, and both of which have been given except the Lake Superior method. The ore taken for assay is a clean sample of copper pyrites or copper matte. Now here are the method for copper assay. The sulfur in the ore or matte is eliminated by roasting. The oxide thus is formed to reduce metallic copper by fusion with potassium cyanide. The apparatus, the usual scales, old furnaces for roasting and fusion. Reagents, ammonium carbonate, charcoal, and charcoal borax glass, potassium cyanide. In weighing the details for copper assay, weigh in duplicate 10 gms, finely powdered ore or matte, and carefully roast as before described. Remove and mix with 1 gm of ammonium carbonate, then re-roast or remove, mixed with 1 gm charcoal, re-roast, then remove again, cool, mix with 30 grams KCN and 3 grams borax glass, place in a number 5 Hessian crucible, and cover with 10 gms KCN with salt. Fuse in a bright red fire for about half an hour. Remove and pour the charged coal and collect and weigh the copper. So here we will be tackling the calculation and accuracy, etc. The result multiplied by 10 gives the percentage of copper. With clean mats containing no antimony, lead, or etc., that results accurate within 2% may be obtained, and still unless the inexact nature of the mat be known. This method is too uncertain, and as before, remark must be given place to other more accurate methods. Now keep the fire between the dull red and bright red, that is a red, and never let it rise above a bright red. The time of fusion varies with the fire and ore, but at the end of 10 minutes, the cover may be removed and the charge inspected now and then, replacing the cover and coke after inspection. When frothing cease, allow the charge to remain in the furnace for 5 minutes. After that, we will pour into a hot grease conical mold after withdrawing the wire loops. Any adhering pearls of lead being removed by washing the wires in the slag. If the top edges of the crucible have cooled, now a red heat the charge should not be poured. So dili nato i-pour. The button is in this case removed by breaking the crucible when cold. So ato siyang i-remove ang button kung bugnaw na siya. Detach the slag hammer the button into a cube and weigh it. Note the result and all the details of firing. Atong i-note sa tanan mga kung sa result sa atong sa atong firing sa result ani ninja. So copper assay, calculation of results. So here diri nato mahibaw-an nato ang the percentage na obtained by multiplying the weight of the button in grams by 10. So multiply nato ang ijang weight sa grams, weight ang grams times 10. Tapos accuracy of results, a difference of opinion exists as to the merits of this and of the cyanide methods. Neither is as accurate as the gravimetric estimation. With a fairly clean galena, both methods give results with an error plus or minus of 1 unit. On the whole, the evidence is slightly in favor of the cyanide method, but before proceeding further, the student must continue his practice till his results are uniform and satisfactory. So, magbalik-balik ta na hantod ma-plaster na. Even if he has to run through 30 or more assays. So, mao lagi to try and error hantod na bisan pag moabot ka pila ka 30 ka mag-assay ta, kinahanglan ato ng ma-perfect or ma-plaster into a satisfaction. The time so employed is amply repaid by the confidence gained. Second method. So the apparatus as before, the same lang. Reagents, potassium cyanide salt. So mo ni ang atong details nato gisunod. Weigh out and duplicate the following: ore 10 gm, cyanide 10 gm grams, salt cover about 5 gms, then mix, charge, cover and insert in the furnace as usual. Fuse for 15 minutes between a red and a bright red, firing as before. Pour and weigh the buttons. Accuracy of results. Now here we shall practice again, and care are necessary. With a clean, rich galena obtained, but when impurities such as copper, antimony, bismuth, etc. are present, the results are worthless. So mag-utro na sabta if na mga impurities na makita. Now to prove this statement, let the student add one of his charge, either antimony or copper, and then examine the resultant button. So iutro na pod sa katong student na naghimuan ni pa-add og antimony and copper or copper. From this, the student will gather that before assaying a strange lead ore, he must examine it qualitatively for this or similar substances. If this be present to any extent, fire methods must be replaced by wet processes. Zinc assay. All zinc compounds are either soluble in or are decomposed by boiling with acids. Now the zinc going into solution. Zinc forms only one series of salts, and these are colorless. So ang kuha nila is colorless. The characteristic is solubility in an alkaline solution. Zinc is detected by dissolving the substance in hydrochloric or nitric acid, boiling and adding sodic hydric in excess, filtering and adding ammonium sulfide to the filtrate. The precipitate contains the zinc, which can be dissolved out by boiling with dilute sulfuric acid and detected by the formation of a white precipitate on the addition of potassic ferrocyanide. Dry method. The dry assay of zinc can only be made indirectly and is unsatisfactory. Zinc is volatile and at the temperature of its reduction is a gas. It is impracticable to condense the vapor so as to weigh the metal. Consequently, its amount is determined by loss. The following method gives approximate results. To take 10 grams of the dried and powdered ore and roast. Now first, at a low temperature and afterwards at a higher one with the help carbonate of ammonia to decompose the sulfates formed, to cool and weigh. Materials will be present as oxides. Mix with 2 grams of powdered coal and charge into a black lead crucible, heated to whiteness, cover loosely, and leave in the furnace for about a quarter of an hour. Uncover and calcine the residue, cool and weigh. The loose in weight multiplied by 8.03 gives the percentage of zinc in the ore. Wet method. Solution and separation may be affected as follows. So treat number 1 or 3 grams. Treat 1 or grams of the substance with 10 or 33 of hydrochloric acid or aqua regia. Evaporate to dryness. Take up with 10 of hydrochloric acid and dilute to 100. Heat nearly to boiling. Saturate with sulfurated hydrogen. Filter and wash with water acidulated with hydrochloric acid. Boil off the sulfurated hydrogen and peroxidize with a few drops of nitric acid. Cool, add caustic soda till nearly but not quite neutralized, and separate the iron as basic acetate by method described under iron. Now the solution will contain the zinc together with any manganese the ore contained and perhaps traces of nickel and cobalt. If the zinc is to be determined volumetrically and manganese is present, this latter is separated with carbonate of ammonia, as described further on. But if a gravimetric method is used and only small quantities of manganese are present, it is better to proceed as well if it were absent, and to subsequently determine its amount which should be deducted. The iron ore or nail method principle. This is for the iron assay. Sufficient soda is added to flux the silica and an excess to give a fluid alkaline slag in which the FeS or iron sulfur formed by iron silica formed by the iron introduced and the sulfur in the pyrites may dissolve. The sulfur present acts to certain extent reducer. Therefore, if a button of 15 grams is required, this would be obtained if about 2 grams were present, that if 30 grams. Now, when less than of FeS2 is present, charcoal or argol is added as a reducer. If more is present, nails of iron wire is added. A preliminary assay will be given the necessary information. Borax is added to flux. Any Fe O that may be formed by oxidation of FeS. Apparatus and reagents. As we can see, we have 30 grams of ore, 25 grams of red lead soda, 30 grams, borax 10 grams, and 1 grams to 0.0 grams according to the trial for charcoal. As a preliminary, mix charge and fuse one charge using no charcoal. Then examine the resulting button, noting its weight. If too small, a button is obtained, and add sufficient reducer to bring down the required lead. If too large, and add another nail or wire loop. So this will be the details for the apparatus and reagents for these minerals. So iron assay. So the assay proper is conducted as before, the fire being kept at a dull red for 5 to 10 minutes. So ang kalayo na ito gigamit ani is kinahanglan na ara siya sa dull red for about 5 to 10 minutes, and then at a bright red for another 10 minutes. So after 10 minutes, mag-add na po patuda-tudahan na to o gamay ang kalayo for a bright red sa 20 minutes. The nails or wire are washed and removed, and the charge poured, and the remainder of the operation and the calculations are conducted as usual. Accuracy. From the data available, it seems that this method gives good results when applied to ores containing less than about 20% of FeS2. Only a certain amount of iron cell can be dissolved in the slag, and any rise above this saturation point results in the formation of a regulus in addition to the lead button. The addition of more iron only partially remedies this evil, so that the scope of the method is limited. Now, we will be tackling the instrumentation methods of analysis. First, spectrophotometry. This method for the determination of a small amount of copper in tungsten metal powder using the principle of solvent extraction has been developed. The metallic sample is dissolved in hydrogen peroxide, tartaric acid added, the pH adjusted, and the excess peroxide destroyed by boiling. Now, copper is reduced to the cuprous state and reagent nicoprine. This color complex is then extracted into chloroform, and the absorbance of the separated chloroform layer measured on a spectrophotometer. Copper contents as low as 1 ppm or parts per million can be determined. The method is limited to finely divided tungsten powder. The organic reagents now commercially available make possible many extremely sensitive colorimetric methods for the determination of metallic ions. This general approach has the added advantage that no special equipment beyond that normal found in an analytical laboratory is required. So, we have the XRF and XRD, which are X-ray fluorescence and X-ray diffraction. So, XRF is a prepared sample specimen excited by the radiation of an X-ray. This causes an and electrons from the inner electron shells to get knocked off. So this fluorescence radiation is measured by the detector. Generation of the XRF's X-ray fluorescence radiation is shown below. One electron from the K shell is knocked. So the resultant voids are filled by either an electron from the L shell or an electron from the M shell. Meanwhile, the Ka and the Kb radiation are generated, which is characteristic for the particular element capable of XRF measurements. Now, XRD or X-ray diffraction is a non-destructive test method to analyze the structure of crystalline materials. It is often used to identify mineral and metal compounds within a solid material or to identify the source of unwanted deposits. The XRD analysis process are typically samples submitted as solid mineral or powdered form. The solid materials are milled or ground to a fine powder and placed on the sample stage. Here, X-ray diffraction patterns are produced by a goniometer, which is rotated at a specific angles while bombarding the sample materials with X-rays. The diffraction patterns' peak intensities are determined by the distribution of atoms within the lattice. The X-ray diffraction patterns is specific to periodic atomic arrangement in a given material, which is compared to the ICDD standard database of X-ray diffraction patterns for phase identification. Now, these are its capabilities: identification of powder metal and mineral compounds, quantification of primary and minority crystalline phases, quantification of preferred orientation, measurement of residual stress in metals and ceramics, measurements of crystalline size. Now, the difference between XRF and XRD is that XRF analyzes for chemistry while XRD determines the mineralogy. Now, XRD identifies and measures the presence of amounts and of minerals and their species in the sample, while XRF produce an assay by giving information on the chemical composition of your sample without indicating what phases they are present in your sample. Here, you can see that both use an X-ray source and detector. Ang XRD o ang XRF nag-use og X-ray source and detector. They have both measure the response to X-rays interacting with a substance. Both provide a measurement to help identify a substance. So, mo ni ang example sa XRF and XRD. Now, let's move on to microanalysis. So, microanalysis is one method used to observe pore size directly after magnifying the sample. The pore structure on the section of sample is observed with a certain magnification. The pore number and size can be measured in the field of view with standard scale, and the pore size and distribution can be calculated, in which the pore size distribution is the percentage of the pore numbers in different pore size ranges. Pore samples with smooth section are prepared, and then the pore numbers within specified can be read a microscope or a projector. As a matter of convenience, they are taken as spheres with a diameter, and the following equation can be derived as D is equals to L all over 0.785 squared, or L all over 0.616, where D is the average diameter of the polydron and L is the average chord of length of the pore. Now here in microanalysis, it is a statistical method, and there must be enough pores for observation in order to obtain the representative results. An optical microanalysis of the sectional pore size distribution has been introduced. Within the given optical image, the section area S for each pore can be taken as the area of a circle with diameter of dp. However, the obtained dp is uncertain due to the possible tilt of the plane with the pores. So, I hope you have learned for my report for the final project for techniques in metallurgical analysis. And that's all. Thank you.